Hi all, welcome to my channel. In this video, I'm going to share you the most important concept of synchronized blocks. This is the ongoing series of Java concurrency in a new way, where I have basically explaining everything very in depth with a real world problems and also all the executable codes and sharing everything in the GitHub. So as part of this video, we are going to discuss about synchronized blocks, which is the very important and the core concept in entire concurrency, like entire Java concurrency. Let's see. Yeah, so now let's talk about like a synchronization. So what exactly synchronized, right? Like Java provides a concurrent mechanism called synchronized to control access the critical sections. Like, so for example, in your bigger code base, or there will be some critical sections where you don't want multiple threads to be modified. You want to access, but you don't want to be provide any inconsistencies, like the outcome shouldn't be any inconsistencies, right? Outcome should always be consistent, like. So that's why Java provides a synchronized keyword to control the critical sections, which will make sure exclusively only one thread can only access the particular resource, like, and prevent the any data inconsistencies, like. So properly using synchronized keyword, we should know the how to use the synchronized keyword properly to build any concurrent scalable applications, like in Java. So let's talk about like synchronized block. So a synchronized, we have like a different type of synchronization, and how also we have like a different ways of synchronization. We'll talk in a bit, but let's talk understand what is synchronized block, right? A synchronized block in Java is a block of code that is basically synchronized on some object, like. So I'll talk about like what is basically on what level you can apply synchronization, like. So within a synchronized block, it is sure that only one thread can only access that particular block. No other thread can access the particular block, and remaining all the threads who are waiting for that block should go in a waiting state. So this is what we call synchronized block. Now let's understand difference between the object level locking and class level locking. You can apply synchronization on an object level, or you can apply synchronization on a whole class level. So what is the object level locking, right? For example, if you apply synchronization on an object, which means, for example, you have a class, right? Class can have multiple objects. So for example, a class A can have an object A, which has, so likewise you have like A1, A2, A3, so A100 objects. So whenever you are applying a locking or a synchronization on an object level, it is making sure that multiple objects, for example A1, A2, A3, can access the critical section concurrently, like whatever you are basically trying to put in the synchronized block. But for example, we have a object, you have a class object where you have basically multiple threads are basically accessing a single object, only A1. So that's where basically the object level locking prevents accessing the multiple threads. If multiple different objects can still access that concurrently, but if multiple threads trying to access the same object concurrently, that is basically preventable with the help of object locking. Like whenever you apply lock on an object level, so only that object will be blocked to if multiple threads basically trying to access that particular object, that particular resource with the same object level. So only one thread can go at a time, like. So once the thread completes its job, it's out from the thread, out from the particular block, other thread can keep on process, like. So this is basically object level locking, restricting the locking at an object level. Still multiple concurrent objects can keep on access the synchronized block, but when it comes to object, only one object can go, like. If the same object tries to like basically if different threads tries to basically work on the same object, it will be blocked. So now what is class level locking, right? So as I said, it's a contract, like. So we have multiple objects of A1, A2, A3. So at a time only one object can access. So in the object level locking, A1 can access, A2 can access, but multiple threads of A1 cannot access. Here A1, if A1 is accessing A2 to A and A infinity cannot access, like. So at a class level locking, only one class can only one object of a particular class can only access a particular object. It's applied to the whole class. There are like some scenarios where we require a class level locking. It is suitable to control the static data. So there is one more example, right? Static data is always a class level locking, right? It's irrespective of objects. That's where you can apply this class level locking, like. And for object level locking, you apply for the non-static methods as well. We can see very in depth in programming also. Like let's see. Before that, understand about synchronized methods versus blocks, right? What is synchronized methods? So synchronized methods, as I said, it's basically applying a synchronized keyboard on a method level, which basically you are restricting this method can only access by a single thread. No other thread can access this particular method. But it's a kind of less flexible. For example, you have a very big method, and your critical section is somewhere it's near 4 or 5 lines. Then if you are basically locking the whole method, only one thread can access the output. Basically throughput will basically reduce it, right? Because all the threads will basically keep on waiting. So even though you're in 100 lines of a code in a method, even though you're 4 blocks only the critical section, but you're restricting the remaining 96 lines, right? That's where it's basically less flexible. That's where we can go with the synchronized blocks, which means don't apply the synchronization on top of on a method level. Apply synchronization on a block level. Only those 4 blocks you can make it a synchronized block. So it is making sure that only one thread can only access a particular object, and this will basically increase the throughput and reduce the contention. Let's see what exactly is what are the strategies to reduce contention, right? One is basically lock splitting. So divide the complete synchronized code into multiple small blocks. For example, you have multiple critical sections. Instead of applying the synchronization on a method level, apply the synchronization on a individual block level. That's where you basically increase the throughput, like and also reduce the duration of each lock. And also lock stripping, right? You can apply. You can basically you can see in the lock duration, you can basically apply a timeout for that lock, like or apply locking in the shortest time possible, like that might involve like restructuring the code and move the non-critical resources outside of the critical section and keep the only the minimum code in the critical section and apply the lock on top of that, or apply or use concurrent data structures wherever it's possible. For example, you can use hash map, you can use array list also, but that is not a concurrent data structure, right? You cannot concurrently modify and you cannot concurrently modify it. It will throw the concurrent modification exceptions. That's where Java concurrent package provides the thread safe hash map. For example, concurrent hash map, thread safe array list. For example, copy on array list. So wherever possible, apply these things without blocking, without the synchronized blocks. Because when you apply these things, right, this will basically taken care of like basically locking on that level, like. So and internally it will basically robustly handle to support a high concurrent request and reads and writes. That's why wherever possible apply these data structures. And finally read write lock, right? I'll explain very in depth about read write lock in the next video. But for now, let's understand what is read write lock. Is basically apply exclusive lock on writes, and we can, multiple objects can simultaneously read the data concurrently, but when comes to write, everything was blocked till the write was done. That's where it's a kind of two level of locking: read lock and write lock. So write is basically exclusive lock, and read is basically more of like allowing the multiple threads to read simultaneously, but locking can only done by single thread. So these are the different strategies to reduce contention. Now what we are waiting? Let's code. So I think this is the previous one. Like for example, where is our synchronized block? Yeah, this one, right? Synchronized block. Okay, now let's create a class. Simple class. Let's create a class called counter. Yeah. Now, for example, a counter has basically int. Let's for example maybe counter. Let's initialize. For example, let's initialize the constructor. And let's discuss about what is object level locking and class method of synchronized block and synchronized method, right? For example, if you create a public for example void increment counter, right? What it will do, it will just increment counter counter plus plus, right? So here this is basically if multiple threads parallelly tries to perform operation. For example, you can create a thread thread 1 equals to new thread for example new counter let's initialize with 0 dot increment counter, right? Okay, for example yeah, now let's create a thread, and here let's do a for loop for int I equals to 0, I less than, let's say 100, I plus plus. What you can do, you can perform the let's create an object as well, counter object counter 1 equals to new counter and initialize with 0. So ideally the expectation is to have a counter 1 dot increment counter, right? So what it will do, once you're done, you can basically public integer get counter you can apply, and you can return the counter. So outside of for loop, once you're waiting, once your threads basically thread one dot join you can catch the like interrupted thread interrupted exception. Let's ignore for now. Inside here you can basically print the system.out.println counter 1 dot get counter, right? So here only, so what is the output? Any guesses? So I am basically running this 100 times, 100 in thread. So thread is started running. Yeah, because yeah, sorry, I didn't start the thread, like thread dot start. Shit, sometimes it will happen. Like, yeah. Now what it will happen? Ideally, the expectation is to have a 100. So is correct because only one thread. Now let's include another thread also. Let's mark it as thread 2, and let's start thread 2 also. And let's wait for thread 2 to join. Now what is the expectation? Generally 200, right? But it won't get 200, like okay. So ideally in the larger values, generally it won't get 200. Let's see. See, 1649, right? So initially get, because that is basically thread nowhere overlap happened, but this time it basically overlap happened because of like a long waiting process. Threads will concurrently try to access. Now how to prevent this one? So apply the synchronization on the complete method level. So you are applying the synchronization on a method level. This is basically blocking the whole increment counter itself. But this is the only critical section, but you are blocking the whole method. This will guarantee every time it's every time 2000. How many times you run, you will get 2000, because only one thread will go. One thread will basically keep on updated, and the outer thread will basically know how to like basically update, right? What value to update again. So this is basically block level method level synchronization. But let's say there is a big code is there, big code, and also big code is there. So you are basically, if you are applying a method level synchronization, you are restricting to stop everything, right? but this is the only critical resource. That's where you can remove this method level synchronization and apply the block level synchronization. For example, this you can apply this block level synchronization, which is basically won't stop this one, won't block this one, we don't only block the synchronization. But this will basically gives the better throughput, but still answer is consistent, right? It's always 2000 like. So this is the difference between the applying the method level synchronization and also block level synchronization. Now let's see about object object locking and class locking, class level locking, right? So whichever, for example, in this case, this is also we called as basically object level locking. So whichever this is the counter one, right? Counter one is basically currently accessing this object, right? So which means it is basically locking on the object level. If you want to apply the class level locking, you can simply replace this one with the counter dot class. This is nothing but a class level locking. You are basically locking the synchronization on a whole class level. For example, you have another counter, like for example another counter, right? So maybe you can mark it as counter 2, and let's say thread 3, thread 4, counter 2 you are basically incrementing in thread 3, and thread 4 you are basically starting all those threads, and you are again waiting. Okay, thread 2, thread 3, thread 4. So ideally, like I should have okay, you can system.println counter 2. So if I run the program, so program is same, it won't happen anything. It will just give the value as like basically 2000, but it is a kind of performance degradation, because only this we are applying the whole class level, right? You are not applying on the object level. So this will basically taken some performance, because this is basically counter 1 is basically doing its own counter, and counter 2 is basically incrementing its own counter. Then why to have the class level synchronization, right? That is not a good way. So we should apply the only object level synchronization. That will basically improve the throughput as well, and a response time also, like. So generally you will get to know when we have the larger data, but when to have the meaning of basically class level locking. For example, you're creating have you know about design patterns? I have already robustly talked about all the design patterns. Among that we have singleton, right? Singleton is what exactly singleton? Class singleton, you have basically one static, basically one public static get instance is there, which will public static singleton get instance is there. What is the job is to create only single object, right? Which means that if we should apply the synchronization, for example singleton dot class level. So for example, if singleton so for example, if singleton equals to null, static, so singleton equals to null, then we basically went into synchronize a block and creating a creating a singleton equals to new singleton. So here you basically you can create a default constructor, that's not a big issue, like you can create a constructor, so this is basically try to then return this singleton, right? So this is the single, you are basically locking on a class level, so only one object will basically comes, like. So here you can still apply like if this is the pure level of object singleton is basically applying a doubly locking. um, Yeah, so this will basically guarantees that you are applying a class level locking. No other if multiple sets is trying to create a get instance, it will blocked on a class level till the object created. Like from next time onwards, basically it will always returns the single object only, single and right. And what other use cases are there for a class level locking? So for example, so maybe like some examples, like for example, you have logging the data, like wherever you are printing the logs everywhere, and you want to write the log data parallel to the file, right? So which means that everything should be happen in a sequence way. That's where you can apply the locking on a class level, like it will make sure that only one object can access. So one object writes the whole data and second object will basically append the data, like that's where you can, that is a one use case apart from this class level locking, right? Apart from this singleton, that is also one use case to apply the class level locking, like. And what other use cases are there? For example, let's define a banking application. Let's say bank application. In bank application, what is there? Like withdraw, deposit on an amount, right? Public double amount. You can perform two operations. Public. You can apply the synchronization. Void. Let's say deposit, right? Deposit amount. Double amount. And you are updating. Make sure only one will access, like. So if you are basically having multiple hold big method, you can apply the block level on this method. So which is amount plus equals to amount, right? And okay, add amount. You are basically adding the amount, right? So now basically public synchronized void withdraw. While withdrawing amount, while withdrawing let's say it is also same, right? Withdraw amount. So here also you can simply apply amount minus equals to withdraw amount, right? And these should be very synchronized way, like. Also you can basically check if amount basically greater than whatever we are trying to withdraw, or amount is basically less than basically equals to 0. You can basically throw the exception, throw a new like throw new like some exception, illegal augment exception, something you can throw. Otherwise then only you can basically withdraw the amount. And also it is good to keep this is only this in a synchronized block, and you can remove this one as synchronized section, right? Only you can mention the synchronized on this yeah. And yeah, what else is there, like and also both should go in a synchronized way. For example, I have a class called transfer service. What it will do, from account to account, right? I'm basically transferring from account to account. Public void transfer amount. So during transfer amount, account maybe bank application from, and bank application to, right? So here you will apply the, so here you have a transfer is there. You are basically, you should basically synchronize on object level, right? Synchronize on the from object level, and only one will access, and inside the synchronize on two object level. And here you are basically from to 2, right? So from dot withdraw, for example, maybe amount also we need to declare, like double amount. From dot withdraw amount, at the same time 2 dot deposit amount, right? We're basically withdrawing withdrawing and then you're depositing, right? So this is how you apply the method level synchronization. So you can also test this application like for example, transfer service equals to new transfer service transfer service dot transfer new banking application. For example, I have 1,000 rupees. Okay, let's say bank application of from equals to new bank application. Initially I have amount is around, let's say 1,000. Okay, so I don't have any constructor. Let's create a constructor like uh, generate constructor. Yeah, from and to as well. So now basically I'm basically doing this from operation, and I'm doing this to operation and 500 amount. So from dot maybe you can expose one more method called balance. It doesn't require any getter. Let's say get amount. That's a kind of a get balance, right? Get amount. You can just print from dot sorry to dot get amount. So even though how many multiple threads access parallelly, so everything basically works fine, right? So always so illegal argument exception like so if amount is basically okay, sorry, if withdraw amount, right? Withdraw amount is basically greater than amount. So you see deposited basically withdrawn and basically deposited, like. So this is how basically you'll define a synchronized on the object level and synchronized on a class level, like. So and yeah, so basically we have demo, we have basically we can also talk about like read write locks. For example, read write for example, let's say I thought of discussing more in like next video, but I'll just give a glimpse over here. Read cache data. Assume that we are doing cache data. So for example, let's declare a read write lock. Lock equals to new re-enter and read write lock. And for example, what cache will do, get call, right? Cache will have a get call on, for example, a resource. For example, you have map, right? Map of string comma maybe string cache equals to new hash map. Now if get of string value, maybe you can say key string, right? Here you can basically, while accessing, you can apply basically lock dot only read lock, and you can basically check like if map dot if cache, right? If cache dot contains key of key, you can basically return cache dot get, right? Get of key, get of key, and you can basically release the lock. So you have the read lock and you have to perform lock, right? You should lock, and you're basically releasing that read lock. When it comes to, for example, So for example, so think of like there is a put method also there. In a put method, for example, return for example null. There might be void. Put method is also there. In a put method, you have a string key will be there, and string value will be there. Here you will apply the lock dot write lock dot lock. You basically apply if you can apply directly, like basically this is a normal thing, right? Like key comma value, and you apply the lock dot write lock dot unlock. So it will basically guarantee that whatever method mentioned in between, only one thread can only access. Here multiple concurrent can access this one because it's a read lock. The write lock is a basically exclusive lock. So this is the one of the ways to reduce the like thread contention, right? Like, so these are the different strategies. We anyway will discuss more into the more while discussing about locking strategies in my next video only. Like so next is basically we discuss about like volatile and atomic. In the further video we'll discuss about like all the different lockings like read entrant, read write, and semaphores. We'll discuss more about in depth on that. And also this volatile atomic also very important concept and very confusing. Let me help you like to clear these concepts. And yeah, that's it for this video. We'll soon meet in the next video. So if you please like the video, if you like the video, please like and subscribe and share to your friends. That is the only thing you can do for me. Like, thank you. Like.